In this video, we will be graphing sine and cosine using period, midline, amplitude, and phase shift. So let's graph problem number 5 here, and we're going to graph as many points as will fit on this graph. All right, we're just going to fill up the whole graph and be happy about it. Okay, let's start with the period. We use this little formula for the period. Period is 2 pi divided by the b value. The b value is this number right here in front of the x in there. So that's why we're going to be doing 2 pi divided by 4. 2 goes into 4 twice. So this is pi over 2. So that's going to be the period is going to be pi over 2. So I like to put my period right about here. Okay, so this is pi over 2. That means right here will be pi over 4, because that's halfway. That means right here will be pi over 8, because that's half of pi over 4. And then this third one is going to always be 3 of the first one, because it's 1, 2, 3 of these. So this will be 3 pi over 8. So that's how you label the x-axis. Okay, now the equation of the midline is going to come from this vertical shift right here. So that's why the midline is going to be y equals -5. Don't forget your y equals. Alright, and that's why we have this extended extra long graph. So -5, 1, 2, 3, maybe I should label this. -1, -2, -3, -4, -5. So our midline will be right here. Okay, so there is our midline. Now, the amplitude. The amplitude is going to come from this number right here in the front. Alright, but the amplitude is always positive. So put +4 right here, not -4. So amplitude tells us how far above and below the midline we're going to go. So it's time to sketch our skeleton graph, and understand that we are dealing with the sine function. Alright, so let's decide where to start. So remember, when we graph these functions, we're thinking of 5 key values that will help us sketch the graph throughout one period. Now, if you're talking about the sine function, and this horizontal line is not necessarily the x-axis, it is the midline. Notice how, regardless of whether the leading coefficient is positive or negative, the sine function always starts out on the midline. So you can start on the midline and go up if it's positive, or you start on the midline and go down if it's negative. Okay, cosine, on the other hand, starts at the amplitude, right, not on the midline. So we're going to start on the midline. Now this is a negative leading coefficient, so we're going to start on the midline and we're going to go down first, like this, down and then up and back. And we're going to go do the amplitude, of course, of 4. So let's do what I just described. So starting on the midline, okay, so your first point is going to go there. Now we need to go down the amplitude. So the amplitude is 4. So as I go to this first mark, I'm going to make sure I go down 4. Okay, as I get to this next position, I'm going to be back to the midline. At the next position, I'm going to be up the amplitude. So I'm going to be up 4. Alright, and then in the final position, the end of the period, I'm going to be back down to the midline again. So my skeleton is going like this, but do not connect the dots so far, because we haven't done the phase shift yet. So the final graph will be either to the left or to the right of this if there's a phase shift. So let's talk phase shift. The phase shift happens when you have something being added or subtracted inside of here. So if this had been 4x plus 1 or something, or plus pi or something, then there'd be a phase shift. But there isn't anything being added or subtracted inside the parentheses. So actually, in this case, the phase shift is 0. So, there is no phase shift. So these will actually be the actual points of the graph then. So I like to do those in pink for some reason. Alright, because green is not that easy to see, which was fine when it was just the ghost. But now that I really want it to be permanent, I'm going to make it this little slightly darker color. So anyway, I'm going to go ahead and graph this as one period of my function. Okay, so that's going to look something like this. Okay, don't make it too pointy. Should be nice and rounded. Okay, so that's one period of the function. Now let's keep going until we run out of space. Alright, let's plot any more of these points. You know how I did my 5 points? If I can plot any more points like that, I want to continue my graph as far as I can. Okay, so if I continue to the left, alright, so looking at it to the left, I went down and then up. So then next I should be above the midline, again 4 points, 4 squares, 4 units above the midline. And then in my next position I'd be back to the midline again. So I'm just continuing the pattern of up and then down. So I can go ahead and graph that. It would look something like this. Okay, and let me continue this in the same way. So I went up and then down, so I would continue this down and then back to the midline. Okay, so this pink area is the one period, but let's go ahead and just draw as much as we can, and then that would include the purple. So that's it for problem number 5 or whatever this was. Okay, let's do another. Let's do problem number 6. That's 0.5, 1/2. Okay, so the period is going to be, all right, 2 pi over the b value. In this case, the b value is 0.5 or 1/2. Okay, so that makes the period is going to be 2 pi over 0.5. Well, 2 divided by 0.5 is 4. Okay, so that makes this, the period is going to be 4 pi. So let's go ahead and get that in the picture. So here's your 4 pi right there. Alright, that makes this 2 pi, and this is going to just be 1 pi, and that makes this 3 pi. Okay, now how about the midline? The midline is normally we can see it because of a vertical change. Like if this was a +7, then I'd know the midline would be up 7. But there is no number there. So that means the midline is y equals 0. Right? Because it's like +0 when it's invisible like that. In other words, it is the y-axis is the midline. Did I just say y-axis? The x-axis is the midline. So that's nice. Now the amplitude is going to come from this number here in the front. The 8, alright, is the amplitude. So I might as well go ahead and mention, there's nothing added or subtracted inside the parentheses either. So I can already tell that there is no phase shift. Alright, if this had been 0.5x plus pi over 4 or something like that, then I'd have a phase shift to the left, pi over 4. But in the absence of anything being added or subtracted in there, there's no phase shift. So, okay, that makes it easy. So I can just immediately go to graph this without having to worry about a skeleton. So here I go. This is the cosine function. Now as we look at our models, remember that cosine starts off not on the midline, but either above the midline at the amplitude, or if it's a negative leading coefficient, below the midline at the amplitude. So this is a positive cosine, so it's going to start off above the midline at the amplitude. Okay, so I'm going to change the scale on this so I can fit it on this graph right here. So the amplitude is 8, so I need to be able to go up 8 and down 8. So I'm going to count by 2's here. So this is, I'll let this be 2, 4, 6, 8. And this will be -2, -4, -6, -8. Alright, it's important to label both your x-axis and your y-axis. Okay? In fact, really, I should have done that more thoroughly on problem number 5 and gone like 1, 2, 3, 4, 5. So make sure you do that. Okay, anyway, so now I can continue. So cosine function. So I'm going to start off at the amplitude, and then I'm going to do the pattern. I'm going to go to the midline, below the midline, back to the midline, above the midline. Okay, so here I go. So in this first position, I'm to the midline, and then I'm below the midline, using my amplitude. Okay, and then back to the midline, and then up above the midline. All right, up 8 and down 8. That's my amplitude. So this period, this one period of the function is going to look like this. Okay, now let us graph more of the function, as much as we can fit on here. Okay, let me use green so I have even more contrast than the purple that I did last time. So if I continued this, I'm up at the top, so I'm going to clearly head back down again. So that would put me here, alright, on the next position. And if I kept going, alright, it's going to keep going below. So it would put me here if I continued. So if I continue the graph, it would look like this. Okay, so we have our one period here, but we need to graph as much as we can fit according to the directions. So of course, if I kept going, this would go down to the midline and then below the midline if it kept going. So this would go like this. Alright, because sine and cosine go up and down forever. So if it's up, go down. And there you go. That's it. That's the final answer for number 6. Alright, I'm going to go ahead and stop this video here. We have more examples to come. So look for more examples like this in the next video, where we will have a phase shift. So in the next video we can find out exactly what to do with a phase shift when it exists.